I'm afraid that when the bubble bursts, again, the robotics will go to an era of darkness. And that is a fear that I carry though. I think I
Okay.
did the full
Yeah,
walk
you
through this.
painted like a really interesting picture and brought some elements from history of how certain technologies have evolved, and it's like a lot to process.
These are all companies that have created a large ecosystem under them, massive operations. That if you do the Thanos snap and then some of these companies vanish, we take it for granted. But if they vanish, right, the world will come to standstill. And if you want to build something on this, don't go robotics engineer. That's a useless course to take. Start learning
Okay.
the fundamentals. This cost dynamics of product pricing is something people don't understand really well. Price is always a problem of volume. It's not the problem of some technical innovation. I would still largely attribute most of my skills to that schooling than my
Oh,
college. And I always have wondered about vision per se. Like how does vision happen, and what is the basis for
right.
vision? Today there is a lot more to complement in robotic space than to compete. Often our portrayal of from gods to everything that we portray, we have in the human form factor. Nothing that goes into a robot were built for robots per se, robot arms per se, right? So that's how clunky the industry was, right? So they were very gung-ho about software and software-oriented investments, and we have had people ask 1 million users or 1 million in revenue in 1 year. So it is very none of these theses are meant for hardware businesses. You need supply chain, all those components. You can't build 400 components go into my robot.
Okay.
I can't design all of them from scratch. You can't build this in one country. The idea of electric car was older than IC engine. Henry Ford's wife drove an electric car. But it became commercially viable only in 2000. And you need a guy like Elon Musk rallying a whole supply chain under it, because of which the humanoid spike is actually happening,
Right.
which in
Right.
fact has been a response to AI per se. 70 years now, it has been, robotics have always been seen as a solution or application domain for a tech, an upcoming tech, right? It was never treated as an independent technology.
Any particular way you think that these skills could be developed?
It's not about you tinkering with the robot form factor, but we not understanding the problem per se. The problem is the object. So something about the object we're not understanding, and then we're not equipping the robot to handle those aspects of the object. The machine doesn't know what to do. The decisions for the machine has to be done by a system. That system is absent. Next 2 to 3 years, every day you'll have new grippers coming in. I mean, your
Right.
LinkedIn posts are largely like
Yeah.
plethora
There's
of different
every
machines,
day
and
there's something new coming
every
up.
day something keeps
Exactly.
coming up,
It's
right?
crazy. Hi, Gokul. Thank you so much for doing this. To start the conversation with, I would ask you, how is it that you would introduce yourself today?
Supriya, firstly, thanks for having us be part of this podcast. And um, to answer your question, I'm just someone trying to address the missing gaps that robotics have today. And my name is Gokul, and I've been at this for more than now 16 years now. In total, must be around 20 years by now. Entirely working on this one single problem of trying to handle what robots are not able to do today, and what it takes to kind of make robots penetrate tasks that they are actually meant for, make them true to the name robot. Like today, they are basically machines. They're not actually robots per se. I mean, we have a personification issue, just like how we believe Superman movies, and we think that we could also jump as much as they do, and that physics is cheating. The same way we get illusioned by the human mimicking motions that they make, but there's not much behind that. It's a lot more of coordination that we do today to make the robots do that. And it's more of a human mind behind it than a robot's own mind trying to do something behind them. So that missing gap is what I, by which per se, Cynlr also tries to kind of solve specifically for robotics.
Okay. Right. Like nowadays, much of your identity kind of revolves around work, like most of the people's identity. So I guess that becomes like a major driving factor of who you are. I would go way back into your childhood, just to understand like where were you born and a bit about what did your mother and father do. I think much of who you are is kind of shaped way back in your childhood, and of course over the years there are many influences that come your way and then they change the way you are or
So
you think. But let's
True.
just go back and just give me a bit about it.
I think this will be a I come a little bit in the way I actually think about it. I come from a little complex background, not a very simple, structured set of life. I was born in Salem in Tamil Nadu. It's a
Okay.
small town. It's a mid-sized town, maybe. Um, I'm originally from the N in my name stands for Namakkal, which is a neighboring district. That's what my father comes from. I'm a
Okay.
farm boy, grown up entirely in a farm. Yet I also had a very good schooling, surprisingly enough, because this is like a farm that is right at the edge of a city, right? So it's the last
Okay.
standing, not yet converted farm kind of a thing. And I happened to grow up there because my there was familial split between my father and mother, and there was I grew up in my mom's place. My father was engineer too, first generation. Uh, Otherwise, we are still close to our roots, which is basically farming per se. So we still have our farms, and that's where my whole house is, and we stay there and so on. So, but we most of our people, my relatives, and in our community, largely have moved away from farming. It's very industrialized in the way they approach. It's the western part of Tamil Nadu. Things little differently. Most of them use this as a basis for starting a business per se. So business is very strong, something or the other. They use this. Farming is just it's basically staying close to your roots kind of a thing where they just have it. So there is a mix of this. My father was an electronics and communication engineer, and my mother was a geography and history teacher. Uh, pre- Preliminarily was a home science person, and then moved on to that's not anymore taught. But from there to geography, history, and then she had a plethora of different things that she wanted to do. And then I also had interesting schooling. This was a contemporary of Sashi Tharoor's. He had a very small stint in Eckhart in Montfort, and it's a boarding school. So similar to that, there was something called as Holy Cross. That was a school that I studied. That's where most of the exposure came from. I would still largely attribute most of my skills to that schooling than my college times and whatnot. So there's a lot of them are built there. Like that's a school that spends a lot on extracurricular activities, and if a Mars comes close by, they buy a telescope, and then we had the ham radios and things, and it's a very well functional lab and very well exposed space, right? So from there, just you go back home in the evening, you're going and grazing your cow, bringing it back to your even now I literally do that sometimes, but uh, so that's a very different kind of a brought up, so that you had the mix of. And if you are in the farm, mix of both worlds. Yeah, literally. And it also gave, I mean, when you're in a farm, you have to do a lot of your repairs by yourself, right? So you're very machine savvy, right? So when you have large farms and then you will always have electrical issues. You have one lightning storm, your motor's coil will go away, so you will pick it up. You have to recoil them, and a lot of that happens at home in itself. And you have a tractor breakdown, you break it down, and then you start assembling them back. And so there'll always be this, right? And plus, my uncle and all of them are like one is computer science head of department in a college and a professor, and so you're also in a amidst educated folks, right? And they're a little more hands-on, so that makes a lot of portion of what uh, I got comfortable with in thinking machines and so on. So, and independently, my father was very, my interface with him was very minimal, but my father was very inclined towards physics and fundamental thinking. So there were each of them had different aspects. I couldn't say I picked up something from one persona at home. Were like different figures, and each of them influence you at different points in time. Plus, you're very well exposed outside. There are a lot of visitors usually to home, and you pick a lot more of other thought processes and relatives. We had my aunt working in Berkeley, and my her husband working in UMIC, University, Michigan, Ann Arbor, and so on and so forth. So you had a lot of those mix of thoughts that keeps coming in. So you get you won't understand many
For
of
sure.
those, but
Yeah, yeah. For
but
you
those
can't
you
pinpoint,
know
but
that
it's just true. Yeah.
yeah, you
Yeah.
would have those
100%.
vocabulary that you're familiar with. Then you go
Right.
back
Right.
someday, it just starts running in your head. Oh, there is also
Yeah.
those avenues of work. There are these avenues of work, um,
Yeah.
mm,
It's just the way you
and
think about money, the way you think about work,
think
the way you
about
think about
so
dealing with people. Yeah.
correct, correct.
Relationships. Yeah. Yeah.
Sometimes it's also a confusion that it leads you to, because see, on one side I was very passionate about joining defense. It was
Uh,
because of my spectacle that I had
oh,
a 3.5 plus
right.
of power, because of which. So otherwise I was in RDC, Republic Day Parade, and in NCC. I was very passionate about defense per se. Was not so
Hmm.
much towards IPS or IAS or those things, but more passionate about defense. I don't know, for some reason. There's a lot of that talk also that happens because my grandfather's brother was in Air Force, and
Uh,
so in the
yeah.
squadron. I'm not sure what was his role position per se, but there's a lot of that talk that keeps happening. So there are like different influences that you get in
Of
different points,
course.
right? So there's a
Always.
research lab
Always.
influence. My father was in CSIR in Ahmedabad in communications lab before. Then he moved to closer up to home, and he was at the time there was PLCC, power line carrier communication. So most of your telephone used to be happening on power line carriers, not on wireless, right? So he was heading that division in electricity board. Then he eventually became director of engineers in TNEB. So there's a lot of this mix that keeps happening, and I was always fascinated with. I paint. I'm self-taught, mostly not a formally educated in art and painting per se, but I paint a lot. I'm very savvy with colors and things, and I always have wondered about vision per se. Like, how does vision happen? And what is the basis for vision? And I still vividly remember looking at my great grandmother, and then like, why is this face my grandmother? What makes these arrangements? This is like, I must be around like 8 to 9 years old, second to third standard or so. So I'm wondering how this image is forming in your head, and what is that makes me label this pattern as. I didn't understand, like, vocabulary was not there at the time. So this was always an ongoing journey. Light was a fascination, vision was a fascination. On the other hand, manipulation was a fascination. And along with that, you had the engineering, the thrill of making something work, making something move. Any toy that I get, I have to break it down. I was very interested in seeing what's inside then and using the toy. So every toy gets broken down often. That continued till I always use. Even now, I carry. Uh, yeah, I carry a screwdriver kit or so on. So, but also, it's part of the job that you have to kind of have them most of the times, because if you step in, you have to start doing something. I always carry that as a kit. So that opening things, which is actually true for my partner also. Nikhil also is pretty hands-on that way. So that way we had a synergy. So my my growing phase was entirely this. I wasn't very. I wouldn't say I'm academically such a. I love to know a lot. I try to read a lot or understand a lot. More than read, I think a lot. Reading is very less. But I wasn't like very convinced with the academic system per se in terms of the ranking and so and so. It's all last minute. I can make it up somehow, figure in the top few and just manage. I spend more time in building things, even in college times and school times, making stuff, work, modeling things. That's what was my major passion at the time.
Right.
And some biology and botany was my keen interest, simply because I would love to see how organisms, where the intelligence evolves, where the organisms
Right.
kind of come to this variety. Why are they becoming efficient by doing so? And so that was another kind of an
Yeah,
interest.
and
But
most of kind of robotics is also influenced by biology, how things are working.
many a times, right? So because you are trying to
Right.
replace somewhere
Yeah.
or the other an
Right.
animal action or
The
a
same
human
movement.
action.
Yeah. Hmm.
But I didn't think of robotics back in the time.
Right.
Fairly was
Got it.
never a
So,
machines in
when in
sorry.
that duration, like when in that school or college duration, did you first hear the word robot?
I mean, I was aware of robots possibly around like maybe fourth, fifth, uh,
Mm,
around that time as vocabulary, but as into proper discussions like fifth, sixth, Leo movies, right? So I've not watched movies. I
mhm.
saw my first theater. I entered the theater for the first time in my sixth standard because parents were like very, very strict and
Right.
take
Yeah.
me anywhere and so on. So, and then possibly I would have watched twice in a theater. But my school had a theater. Saturdays are movie days. So they will put some science fiction movies or so on. So I think one of the early ones was Terminator, and Matrix is something that was the most passionate and most closest to me. And
Mhm.
Matrix
Yeah.
happened. I was very interested in it more because of the intelligence perspective, where the consciousness comes, and then
Right.
the than the physical form factors are per se, right? So it's most about the way the Vedantic take that they take towards how you could be elusive around
Yeah.
the perception and how you interact and act for your perception and so on. Because that's what was, but that was during college days, right? So it was late by the time. But early days, that
But
was
you
my exposure.
understood that even during college days, like you were in that
Huh.
like
So there's a lot of the discussion
headspace
that used to happen.
already.
Yeah, peer space. You had
Interesting.
just peers who used
Oh,
to discuss this a lot.
interesting.
You had
Okay.
your schoolmates who are like very curious on this. I mean, there are a lot of ridiculous discussion that used to happen. We wouldn't be like
Of
that
course.
that
Of
smart, and then
course.
but
Yeah.
the topic exposure was there. So when if I
Mm,
look back now, like I would think, what are we talking about? But it those topics were there, right? So, and robotics per se was more of a machine extension for me. It was not like recreating a human as an inspiration. For me, I was more motivated by a machine that could solve a very complex problem. And I never believed that robots have to be in humanoid form factor because that is very uninteresting for me. I used to find it very ridiculous that an alien will always look in a human form factor, right? It will take, and because it's easy to communicate in a sheep's face, you can't see the emotions, right? So human beings are, but surprisingly, sheep identify each other through the face. They don't do that through smell, or like dogs do through smell, right? They are very visual in the way they identify each other. But we can't distinguish between each sheep's on the basis of their face look, right? You need other marks. We would need certain patterns, and not goats per se. I'm not sure about the goats, but sheep's particularly, right? So just like that, just like we can't make that expression so often, our portrayal of from gods to everything that we portray, we have in the human form factor. But what I am very fascinated about is a machine that is sophisticated enough, powerful enough, that can deliver like a car for that case is a very, very powerful machine. And Earth mover and excavator is a very powerful machine. A Mars rover is a very, very beautiful machine. A CERN is the cyclotron is a beautiful machine, right? So machines that can self-organize themselves, because organisms also take multiple different form factors. The same earth is walked by so many different animals, right? So from a cockroach form factor to a snake form factor to a bird to a bat so there are a lot of ways to adapt to the environment and to be more successful in handling the variations that the environment poses. So I was more curious about ecologically, why did the system evolve to have these, and how do they help them, that form factor help them tackle physics, right? So handle physics. And that is what eventually led to and independently, there are a lot of things that I wanted to build, but eventually it always the vision that keeps coming back to, because the most intense amount of processing that we do is always visual. And more than 50% of your brain at any given point of time is vision. And And surprisingly, also the biology inspiration that I had at the time, where I, given a choice, I would sit and study about this. But there was a lot of desire to build something big and build something very transformational. So a social transformation or impact on the social structure. So you don't like something about society, don't put placards. Be the cause of why that behavior. It's a collective habit, right? So the habit is for something is optimizing them to behave in that way because they needed something. So that understanding I didn't have then, but suddenly it dawned around ninth, 10th when I have to ask this question. Somehow I very clearly saw that a doctor or an advocate or a lawyer or any of these roles are helping people to use infrastructure. They don't build infrastructure per se. They don't foundationally create something. Engineering is the only job where you foundationally create something, right? Be it from your tower lines to your electric transportation, which is your tower line. I mean, from your mobile communication towers to your roads, tar, buildings, anything that you think about that we consume today has come through a design, an engineering design per se, right? And that makes us talk in English today. That makes us talk in, wear this dress today, use this laptop or whatnot. Shapes of habits around this, optimization around this. So it's basically my my need for access to these systems is where um, social collective behaviors start coming about. Now, if you want to change that, if you want to change that behavior, you want something to be done there, then you change the technology that makes your life easy. So if you touch there, then you make very big transformation. At the time, Bill Gates was the lot of inspiration for it's 90s, right? So late 90s, and Bill Gates is like the first billionaire, and so and so, and you want to be that big, and software was the big thing, and so all that. So somewhere engineering want to do all of it, like a jack of all trades kind of thing, want to be everywhere, and that eventually resulted in me taking an instrumentation. There was a lot of hope that I'll crack IIT, but I didn't even attempt IIT exams, simply because I want
Oh.
to be a rebel with my parents, which I think I made a big mistake.
No, it's
Now
everyone. Like everyone in that phase is like going through some
I was
hormonal
dead
changes. So
against.
it's normal.
I was just saying it's just the same book. Just because I'm in that place, I never paid value for teachers or professors. Somehow, I think that's
Hmm.
that's if anyone listens to this, my teachers listen to this, they will be heartbroken. But I never paid much value to that because for me it was mostly so before even the classes start, I would have finished the book. I would know it and I'd have started.
Hmm.
So I didn't find it very very inspiring that they're telling me something that is beyond this book or making me understand it. It's if you are good with English, most probably you can pick it up. It's not very complicated for someone to kind of break it down for you. So for me, it was like the same book. Rather, I want to spend this 4 years building something. So right from the
Hmm.
first year onwards, I was very clear that I want to build a product. I didn't have the understanding that I have today, but I wanted to build a product. I didn't want this naam ke vaste projects that you actually show in your final year end. At the worst case, if it doesn't work, I know that I can show the same thing as a project and then get a A out of it. And that's what eventually happened.
Yeah.
I couldn't build it, but half the way through whatever that I built, showed it, and that itself was enough for
Well said.
because
Well said. Yeah.
I found it as a broken system, as this projects and I just wanted to learn engineering. For me, I had a for a very long time I had this philosophy, still hold true to that you read because you need it. Don't read because hoping that it'll be useful to you at some point, right? So for me, the necessity for me to collect that knowledge has to come. Otherwise, it's garbage, right? So the only difference is you collect everything that's there outside and then keep it in your home, it becomes a garbage, right? So you need to organize and keep it. It needs to serve you. If there is a need for it, then automatically you both learn. So from that point of view, I was like, if I'm doing engineering, I want to build something. I always wanted to be building something, start an entrepreneur, be an entrepreneur. That's the only goal because I wasn't so great at physics. Then physics dawned later. Till my 11th, 12th, I was okay with physics. I mean, you score because that you can score. If you'd asked whether I understood the foundations of it, I didn't. Then suddenly, I somehow I got the first year physics book, college physics book in 11th itself. My father buys a lot of these books, and I started learning a little bit on Feynman. I didn't know Feynman back in the time so much, but on the particle physics and so on and so forth. Then it started dawning. The classical physics started dawning more. Uh, and not coming from a CBSE background, there was a lot of state board background. There was a lot of jargonization and often I don't think it's CBSE or anything has a difference per se, but a lot of times we just memorize formulations and equations, right? So and then we move with it. Like if I ask moment of ownership conceptually, there's a lot of things that people don't understand. And if I don't have it, I can't design something from basics. For example, even a chair for me to be designed is one of the interview questions that I always ask. Like why should a chair be of 5 legs? Why not 6 legs? Why this length and so on and so forth? This has a lot of foundational thinking. And for us to be comfortable thinking from that layer where the foundational principles is something that you should be very good with in deriving those principles, not just, you know, putting a name tag and then knowing an equation bunch and then expecting the problem will be formulated to you like you have in your exam papers that they clearly give you a problem. The in real world scenario, the problems don't announce to you. So if I have to pick up that skill, then I thought engineering has to be all about me coming out with an ability to build a product end to end. So I want to build this. What do I need to learn for me to get there, right? And I was very arrogant that I will get to the same place. Companies need IITs or do they need skills? If they need skills, then I'll get to the same place where the IITians would go to, right? So that was the argument with my parents per se. Eventually, I did. And we went to National Instruments. God, there's a lot of luck involved in that too. But when the opportunity presented, was able to kind of there's 9 rounds of interviews and all of that. So we were a
Okay.
bunch of 26 in our first year batch, and at our job. And Nikhil, I met Nikhil there.
Okay. So that
Incidentally,
was your
is
first job after your
after
graduation?
my college, after my
Okay.
graduation,
Okay. So yeah,
and
tell me a couple of job experiences before you started Cynlr, so that we understand if you picked a certain quality or skill during these experiences before you started.
so the way I joined National Instruments was also specifically because see, I was an electronics and instrumentation engineer. For us, the Google is NI, right? So
Hmm.
National Instruments is at the top of it, right? And plus, it's not very well known outside, but in any R&D office, if you step in, NI is always in a epitome,
Right.
right?
Yeah.
So 3G, 4G, 5G, all of these were designed on National Instruments platforms. Their whole CERN runs on NI's PXI systems. Your defense call phishing actually happens on NI platforms, and so it's from your missile launching to everything that you GPS spoofing is on NI devices, and so we do the fundamental crux of the research in or at least support. I wouldn't say we do it. To the researchers who do it, we support those instrumentation and devices and so on. So that gives you a very quick exposure in a very short span of time. And they also hired people like that. We had a very good bunch, really selectively really good engineers from apart from mostly largely from the IIT folks. Few of us were non-IITs also. Some 6 7 of us were non-IITs in the 26 batch and everybody else were. So they that was a good exposure. But the way I joined National Instruments was because I was trying to build this harvester robot for coconut harvesting and so on and so forth. I started with Areca nut first because it's simpler to start with, but that exposed a lot about why robots are so immature. Robotics is space is immature. A human who's 60 to 65 kg to climb this tree, one robotic arm is that heavy, right? So just one arm, right? And imagine being able to lift this up over the tree in an all weather condition. It may have rained, it may have, and then you have to move from one tree to another tree. And imagine the weight it is supposed to carry, and then wear and tear it is supposed to go through, the power that it actually consumes, what is kilowatts of power that it actually consumes. How do you kind of make this all viable? And with all this, it needs to be at a cost cheaper than a tractor. right? A tractor you might actually buy for like I come from a space where it's heavily mechanized. Even from my early days, like late 80s and itself, mechanization began. So we largely do not have workers per se working on the field. Mostly it's tractors and harvesters and planters, and these kind of machines used to be there back in the time. So there was passion for it, but imagine for a crowd which is used to all this, and for them to operate this, even remotely operatable, can I have a system that is cheap enough and that is rugged enough, and so on and so forth. So there is, in while trying to build this, there's a very simple conversation happening between two people in one of the uh, uh, and we always think, gross margin is where the problem is, the efficiency of the organization is where the problem is, marketing cost is so and so. This is cost dynamics of product pricing is something people don't understand really well. Price is always is a problem of volume. It's not the problem of some technical innovation per se. Sometimes it could be, or it is basically large gross margin. It's basically what is the kind of team with which you're able to build what you are able to build and what's the expense of the team and per se, right? That's often is mistook and misunderstood, especially in India. That narrative is very heavy. I'm going to build a low cost. I'm going to build a low cost. Simply means that they don't understand the business behind or how to kind of scale something, right? So you don't understand the unit dynamics or price unit dynamics of a component per se, and why it is going to be expensive. There's two guys who were just conversing. He was just taking one screwdriver, and then I mean, because of this, he was getting inspired, and then they both were conversing in a soldering shop. It's an aluminum soldering shop, right? So they were, and then he was looking at him, and then in colloquial language, he was just asking him, this screwdriver that I have might be in maybe like 1,000 rupees. I mean, might be like, sorry, 50 rupees. If we make it, how much will it cost? Some 1,500 or 2,000 rupees. If we make it at 1,200 to 500 rupees, I mean 1,500 to 2,000 rupees, and that becomes only 50 rupees if I'm buying it. Like, how is this? And then he was just talking about the whole volume dynamics and how. So I learned a lot more from these first principle thinking foundational guys than from the MBA jargons that you'll actually get, right? So it's just spirals more into, and it's more interesting to kind of understand how they understand all this, right? And how much of I mean, how much we trivialize, but they do seem to have a lot of practical knowledge around these things, right? So, and I looked at, then applied that back to the robotics. Then why is a car, which is a ton of material with 22,000 parts, the global supply chain can be as much as maybe my laptop cost, right? So, uh, right. So like 4 lakh rupees, you can buy a car, right? And a robot, which is just 6 motors, and I keep saying, toilet pipes connecting 6 motors. Why is it that expensive? All right, volumes. So if there is volume problem, where is the volume problem coming from? Which means the utility for the robots is very, very small. So people are not buying. The adoption for the robots are not coming to that extent. One of the primary issues was people who were making the robotic arms, they were not treating themselves as components. They were treating that as a product. And they were forcing customers to invent solutions using those limited devices that they provide. And they are also not able to build more because their volumes are so low. The business is trapped per se. The industry in itself, there is no industry per se under robotics. Only now it's brewing. There's no supply chain for it, specifically meant for it. The motors were meant for something else, and then you buy and attach it. So nothing that goes into a robot were built for robots per se, robot arms per se, right? So that's how clunky the industry was, right? And how regressive the industry was. And asking the question of, then why is it that people are not able to find so much utility to robotic arms, then something is missing. Most of the actions and activities that the customers use for is a very fixed environment. Things are like pre-programmed, pre-taught. There are only limited use cases for such an environmentally controlled operations, right? And what are that you could do has already been done, like welding, painting, and that were done in like 90s, early 90s in itself. Adoption took possibly around another 20 years. Even in India, it's a very saturated, well-done market, right? So by 2005 to 6 itself, we started adopting a very large-scale welding and painting shops. Maruti has done that very early on, and so on and so forth. Um, so spot welding, TIG welding, all of this were all done with robotic arms for a long time. So whereas when it comes to mating like those 22,000 parts, it's completely automated. That is because they cannot be controlled. Environment cannot be brought down to 0.2 mm of tolerance, that nothing changes beyond 0.2 mm. Now, for that, you need intelligence per se. Because there is no intelligence that is overlapping onto that, what can a hand do? The machine doesn't know what to do. The decisions for the machine has to be done by a system. That system is absent. That's why these arms don't find that much utility per se. It's not the gripper. Even with two fingers, you could do a lot more work, which you are not able to do today with the robots. Right. So that is the gap in the journey. And then eventually my passion for vision and all of this kind of collided, converged. And that's specifically for what I joined National Instruments, because it had a very strong machine vision division. And this was the world's third largest after Cognex and Keyence. Cognex was the pioneer, but all the special purpose algorithm heavy systems used to be done with National Instruments tool set and so on. So we always had vision and motion together. There was a small robotics division, which both of these were like now hived off. It was then, and then the R&D for vision was here in Bangalore. Uh, some portions of RF and the entire R&D for vision and vision algorithms were here in Bangalore. So that's how we I joined here at National Instruments. So all of us started as engineering training and then moved to different roles.
So yeah, we spoke about some of your experiences before you started Cynlr. So
Yeah.
let's maybe get to the point wherein when is it when you decided that you'll start your own company, and which was your first product? What made you kind of say, okay, I have some this particular idea in my mind, and let me start with that.
I was very clear right out of the college. I was very clear that even at college, I was very clear that this is what I want to build: the stack
Hmm.
for robotics layers, and I mean per se the intelligence layers and the ability for the robot to kind of manipulate by itself. I was very neuroscience passionate also at the time, and with that as the clarity is what I entered National Instruments. Also, my interview question was also on this, and was very clearly on the entrepreneurship. So either wanted to lead this within National Instruments, or if the business synergy doesn't form, then we'll go out and start on this. So there was no deviation. And from the starting, it was just this one problem. And when eventually the time came, so spent there 4 years. Fifth year is when I wanted to. After 5 years is what when I want to leave. But fourth year itself, we saw some synergy. I was hunting for co-founder for a long time, and eventually I had Nikhil. From college time, I was actually looking for someone to start with, and Nikhil was there, and he was synergizing and with this vision a lot. It resonated with him a lot, and he also had his perspectives around this. And then in 2015 April, with blessings of National Instruments, we moved on from NI, and they helped us with some of these unsolved problems that they had in vision and vision-oriented automation. Uh, and we were very clear. So in NI, we used to face this as an industry-wide problem. As machine vision industry, we used to face this problem whenever vision was applied for machine guidance or manipulation of objects. It used to fail miserably. So only 3 in like 10 problems will commercially succeed. So only 30% success rate that we had. And all of the 30% used to be identification related problems, barcode reading, OCR, those kind of problems, right? So, and we were at a very early stage of neural networks and machine learning and so on and so forth, right? So, SPM and all the different layers of machine learning. But when it comes to object manipulation, we used to fail miserably. And that's when we kind of had a very strong when I looked back, we were all doing soul searching at NI and also in Keyence, Cognex, all of these places. And one thing that was evident for me, my hypothesis was vision was built more for manipulation and identification as an unintended consequence, whereas the technology as vision that I mean human vision was built that way, whereas or animal vision per se. Whereas the vision that we use is largely not identical to a animal vision, non-identical to an animal vision, and that is meant for like color impressions, right? So image impressions, not a very dynamic data collection, not a motion based imaging or vision system, right? Human vision in fact sees motion first. It has 18 different ways of constructing depth, not just stereo vision. Starts with autofocus first. And the reason why we are obsessed with identification often is like simple thing, right? So you may not have to, like if I show a very weird object you have never seen before, you will still be able to, you're not blind to this, right? You can go and pick it. You can take it from my hand. The robot will stall. It may not know what this object is per se. My ML system will not even be able to label it. It can't even segment and segregate and say so and so. Without that large, a baby doesn't need to know it. It'll go and grab. It'll pull your hair. It'll pull your spectacle, right? It is able to kind of. It doesn't know it's a. It'll put it in its mouth, throw it off, right? It doesn't know it's one continuum of an object. The understanding of how object evolved through vision and touch in human beings is very different from how we have understood it and then try to do that for a machine, right? And so that starts with vision in itself being insufficient, because that's the largest sensor that the human body has. You have more neural endings that between both of your eyes than the rest of the whole body, right? That's the highest density of data. That's why you close your eyes if you're listening to music, if you want to think deep, or if you're tasting an ice cream or smelling a rose. So any other senses you want to kind of enhance or you want to balance, you close your eyes a lot, because you want to relieve the neural activity for the rest of the other region. So somehow we have just reduced it to just identification, with color based identification. That's because the world is buried with a lot of color cacophony. And the object that I want, let's say I want this pen, it does one particular color pattern. I want to extract this color pattern from the background. Then if I'm able to isolate this, then I know where it is located and then go pick it with my hand, right? So, but human eye does not do all this complex color pattern based matching and stuff. It does do autofocus first and says what are all the colors that are in the background, just eliminates them. Then it does, a lot of event imaging and manipulation focused imaging per se, motion imaging per se, to stitch these colors into one particular, because there's a lot of reflective patterns. It's not the same color that you see, right? Right here you would see a white, but in your mind it's blue, right? But in as per the machine it's white, right? So you have this very complex. You had the blue, black, and the gold, white dress illusion that was very famous in the internet, right? So there's a lot of these gaps in understanding, and I formulated a kind of a framework for manipulation savvy perception. And with that thesis, I had close to around like 40 systems that I architected at National Instruments. I also had an opportunity of architecting for one of the world's largest verification validation system, a completely autonomous system. It's close to around 300,000 test cases for your infotainment system, all visually feedback, and then it does all of it. It's RF plus vision. So I evolved to be a specialist in RF, embedded vision, and software architectures at National. So that was my title, specialist at. I had a good growth with the National Instruments. Had purview of India, Arabia, Russia, and Europe, uh, and Taiwan. China, Japan, and US was like their own. They had their own space. So with that background, with some of these unsolved problems in vision, with NI's help, we moved out in 2015. It's one thing to be backed with like a 6,000 member company, and you
Right.
being one of those, just one part of it. Having all this thesis and all that is fine, but there's so much that supports you
Of
to get to that
course.
point. And for you to come by yourself and then do the same problem, whether it's commercially viable, whether you can build a startup around this, is something that you do not know. So next
Right.
3 years, from 2015 till 2018, we were doing 30 different customer problems, unsolved problems, and we deployed it across the globe, starting from a grain sorting machine, where you have like 220 million grains per hour. It's 1.5 ton to 2 ton of grains. You can naked eye, you can't see. So you have 56 microseconds before which you have to isolate the grain from the background, see what its trajectory is, and then blow them out. And whether say it's a black grain, good grain, is it a rat feces, or is it a, you will not find black rice at all most of the times nowadays. Right? So back in the time, when I was young, we always used to find a black rice and stones and things. So those are all filtered through these, and it's for wide varieties of pulses that you have this. And globally, there are a lot of companies that have been doing it. Bueller is the pioneer in this, and so we did this as one product effort also, because commercially there are no cameras that do this at this speed at 56 microseconds. So we built the camera from scratch, which is capable of doing all this in real time. and only 1 in 15 grains can be a good grain. 15 bad grains can be a good grain. So that's the speed at which it's supposed to kind of operate. And so from there, all the way till assembling a conrod, rock around with conrod, and rock around independently and conrod and bush, and so on and so forth. So a lot of these kind of very hard to solve automation problems deployed across the globe. So once we had that, we preliminarily did it to just challenge and check whether our architecture has some common underlying principle on which it's able to work. So once we had that in 2018 onwards, we started to go to VCs to raise the funding. And we thought 2018 would be a good time. 2015, we first sat and then thought about it. Then Nikhil was of the opinion that, why would someone fund? Back in the time, it was all consumer tech and app aggregation, marketplace aggregation. We had the housing.coms and for everything, app, find, apply app as a solution kind of a thing. And then fintech to some extent was growing. And we thought, okay, so I always had a pattern saying, if there is 10 years of fundamental technology infrastructure the market invests into, in the next 10 years will be exploitation of it to see what all you could apply and then find market with. So that was 1980s of compute, and 1990s was all internet and dot-com bubble. It ended in. And then post dot-com bubble, it exposed the gaps in technology, which in communication and technology, which resulted in next 10 years of very foundational mobile infrastructure, telecom infrastructure, 2G, 4G. We went up to like 2G, 3G, in fact, up to 4G almost 2011, right? So we and once that happened, and we had Android, because nobody was looking at Android all this while. Suddenly, then Android picked up, ARM picked up as a processor. Before that, it was all microchip and PIC microcontrollers, ATmega microcontrollers. PIC was the industrial grade one, right? And IBM PowerPC was the industrial grade PC's alternative for Intel. All this was actually there. Then ARM picked up. Then 2006, 7, I'm forgetting the date, but Apple kind of put together the first touch screen based, capacitive screen based 7, right? So then the revolution started getting into exploiting the platform. All these converged. Then you had opportunities for Ubers to come, Airbnbs to come, and people were looking at all these. So we thought, that will again, once that, and market will go crazy at the time because they want to see what all applications are there and capture the application market, right? But it will hit the saturation. Once it hits a saturation, then you don't know what to invest into. Then it'll come back to the foundations. When we were thinking that SaaS took up, right, in 2018 and 19, and we started with a very big hurdle of market not even understanding. The investment market was highly disconnected from the manufacturing world, and they were very, very uninterested in touching manufacturing and supply chain and physical hardware per se, hardware in itself, right? So they were very gung ho about software and software oriented investments, and we have had people ask 1 million users or 1 million in revenue in 1 year. So this is very, none of these theses are meant for hardware businesses. If you carry that template and then try to observe a hardware business, it will never succeed. It's an entry barrier, right? And then you need to create an ecosystem under it. The other problem that we also had is very unsavvy hardware-oriented entrepreneurs who are a little naive about, like, without understanding the fact that you need to build an ecosystem under you go and promise a low cost, and you not understanding how much it, like, for me to run a $6 million R&D, I need to make a revenue of close to around 150 to $200 million, right? For me to touch a $13 million at the price point of 150 with the gross margin of 50%, I need to make a revenue of $300 million, right? 6% to that's where the 6% R&D cost typically comes, because you need supply chain, all those components. You can't build 400 components go into my robot. I can't design all of them from scratch, right? I'm not the expert in encoder, right? I'm not the expert in a capacitive encoder per se. If I have to manage all of that, that's one. Second, I need to hit volumes which is cheap, which is higher than his volumes that I could be cheaper, that I can vertically integrate per se, right? And the capital investments, and then the amount of infrastructure that you need to put into expertise, the amount of HR work that you need to do. You are in a landscape, and this is a globally sourced technology. You can't build this in one country. You can't be just within one country and then build all of this. You need to be in each of the countries. That the encoder comes from Israel. There's nobody else who's making that encoder, right? Not for the arm, I'm saying for the vision in itself that we use an encoder. That's a small form factor one, which is usually used for defense purpose, lightweight encoders per se, right? So very expensive ones, but it comes from there. There are only two liquid lens manufacturers across the globe, right? Today, motors and motor joints have been hyper commoditized because of China's existence, Chinese market existence. Otherwise, it was all bottlenecked by KUKAs and the ABBs of the world. They have exclusivity towards the entire kit of robot and robot joints and right and the cycloidal gears and whatever that you want to make. Today, that has been a lot more democratized to a good extent in the last 2 to 3 years. None of this were well understood by the investment market, and they didn't have the patience and look at it because they also had an option of supply chain. I'm sorry, SaaS, right? Thankfully, COVID happened. And even during COVID, when we were like in 2019, August, we raised right into the lap of COVID, and then COVID happened. In one way, it's good for us. In one way, it's bad for us. Bad because we lost a good year. Uh, Entire supply chain was completely frozen. We had to wait till 2021 to kickstart all our operations and things. And this is something you need to be physical. And the concept was the HR concepts were not favorable also to us, right? The narratives that were popularly that was being peddled was not convenient for us because I can't operate with a laptop. I need a physical system. I need people who are working here physically. That the whole trend, really good minds, really good talent were all distracted by all these, you know, unsustainable, uh, uh, narratives in HR focused fields. We had the Great Resignation. I forgot what all that was there. There was Great Resignation, and there was Great Firing. There was Great Moving, and all that. That was in that turmoil. A lot of things were actually lost. But and investors were also asking, what could you do towards this? You know, future of work is going to be remote. Could you do something towards that instead of why are you looking at automotive? Why are you looking at warehouses? In fact, they looked at warehouses a lot more because Amazon is investing and so on. So, but they also don't realize that you need to go with the process if you're going into a warehouse. Whereas in an automotive, you don't need to go with the process. They have figured it all out. You just have to go with the machine and technology, but it's very slow. So there are those. So in hunting this, you'll either way lose it, but rather you stick with the automotive and the same 3 to 4 year period with that patience, build something, uh, prove something with the customer, right? So we were betting saying that supply chain will be the biggest risk. You guys are underestimating it. And in 2020, nobody spoke about supply chain as a big problem because manufacturing was not a big problem, right? I mean, supply chain for medical supply chain they were talking about, but they never talked about it'll become a huge problem for your basic commodities, white goods, and consumables that you have and your devices. That all will get affected or something that nobody actually thought about. Electronics is a national security issue, right? Which was realized by around 2022, and it became a sensation. And semiconductor was the first sensation that happened. America started investing close to around $600 billion as raw cash put into Arizona. And I still remember that news article that I was telling them, you guys are running against fake valuation while there is actual raw cash of 650 billion dollars being dumped into semiconductor. And um, so those are the uptick and upwind, the tailwind that we actually got in the last 1.5 years or so, because of which the humanoid spike is actually happening, which in fact has been a response to AI per se, right? So,
Hmm.
if you think about it, that's one trend they are looking at for what all OpenAI created. Could there be for the ChatGPT and the
For
LLM models?
robotics moment, yeah.
Yeah, what
Yeah.
can we? That has
Yeah.
always been the curse of robotics for past 60 years, from
Hmm.
1950s, 70 years now. It has been robotics have always been seen as a solution or application domain for a tech, an upcoming tech, right? it was never treated as an independent technology per se by itself, right? That's the biggest problem. Everybody had the problem of building a car with cycle wheels, right? You can't. You need to build a wheel for the car that's made for the car. So that is one of the primary, neither the sensors are meant for the activity the robot is supposed to do, nor is the motion that is meant for the activity the robot is supposed to do, nor is the grasping ability or the intelligence is built for what robot is supposed to do. So it's all like you're scrambling and scavenging, and it becomes a jugaad space always, right? You're just force fitting things that don't fit well, and it always breaks when it has to meet and neither does it attract the investment it deserves. We are talking about automating the foundation of value, which is effort, right? And that's of the hundred and something trillion dollar that we talk about, $12 trillion is software. Remaining is all physical, isn't it? That's all foundationally. At least 30% of that is physical labor per se, right? And we are trying to automate such a large trillion market, like 30 to 30, 40 trillion market globally. And we are not even investing enough. The global robotic arm market is $16 billion, right? And 48 billion to 44 billion is the solutions around robotics specifically. I'm not talking about the AMR and the logistics and so just the arms, right? So which does the manipulation task. Such a narrow space and very less insight into the space. And thankfully, if it is not for Optimus and Tesla, and their Gangoism in his Gangoism in 2017, and he having to swallow back his words in 2019 that robots can't do as good as what human beings can, and that ego bruised makes them go back and then start saying that why can't we do this? It's the greatest moment of opportunity. Then he comes back very clearly. I believe in what he actually says too, where he says, future is going to be humanoids that we are selling, not the cars. It's a very sensible space to go into, but we are underestimating. That's the only problem. We are seeing it's too soon. If you anticipate that it's going to be another 20 years, then you'll have phased versions of how you could go to the market with early commercializations and make the market fund the rest of the growth of the robot ecosystem. Otherwise, you're hunting for something that is feasible 30 years back and now. And it's not about the idea. The idea of electric car was older than IC engine. Henry Ford's wife drove an electric car. Uh, but it became commercially viable only in 2000. And you need a guy like Elon Musk rallying a whole supply chain under it, right? And we have had Reva. We have had the 90s. Mahindra Reva has been here in India. Even before that, Nissan had been there globally. And so much of electric cars have been there. Nobody was able to make it commercially viable. So it's more about rallying the whole market behind you. There's so many other things executionally that you need to get it right before you can get the whole technology per se translate into a usable, commercially viable solution for your customers. So I think that is where I'm afraid that when the bubble bursts, again, the robotics will go to an era of darkness. And that is a fear that I carry, though.
Mm,
I think I
okay.
did the full, full
Yeah,
walk through
you
in this
painted
thing.
like a really interesting picture and brought some elements from history of how certain technologies have evolved, and it's like a lot to process. But if I may ask that, going forward ahead for next 5 years, if India as a country would need to produce good robotics solutions, which sectors do we get into right now, and what are the things that certain things that the ecosystem um, would require to give to these next generation of entrepreneurs maybe. So yeah, if you can name any top three, so, top some sectors and some yeah, things to add to
So
the
I'll put it
ecosystem
both
idea.
ways, right? So I think
Mhm.
people need to get out of robotic solutions mindset and need to
Okay.
start thinking more into the general purpose robots. Uh,
Okay.
one common form factor that can actually solve for and it doesn't have to be humanoid form factor. It has to
Mhm.
be a large chunk of basically an architecture. Like Compute World had an x86 architecture, because of which you have seen this famous meme, right? So variety of devices that were there in your desk has become just a laptop and has become
Hmm.
just
Yeah.
can you imagine a factory getting simplified to that extent? Right? That's where the opportunity lies. Robotic solutions assume that the robots are mature. So the actual key is in building the gaps of the technology. And I think we need to focus more on the supply chain for robots, than on the components that go into the robots, than on the final form factors, right?
Hmm.
And that is where we could actually compete. And I think we shouldn't be competing with China. When I talk about components, we should be competing with design, on design with Europe. India has the potential, right? Better than even China does. China is mostly a so massive scale, large scale, impossible scale innovation space. It's not an invention space. So the whole world is made in China, but the China is designed in Europe, right? So most of the machineries that they use, all of the fundamental components, everything does come from, legacy of Europe per se, right? Not US, largely Europe in most of the things, right? So um, uh, our competition, we are more, we need to be IP rich, IP centric more, and our play is in leveraging our talent from abroad to be brought in, and whichever the way, brought in or not brought in, to start building more IPs around this. Then the supply chain will follow through naturally. The scale will follow through actually, right? So that said, how do we generalize across several object handling problems? And if you think about, automotive may not be the scaling space for us. That, but that definitely is the handholding space for it to get to the point where the maturity of your productization can happen. There is technology on one side. So maybe even for internal clarity, I break this down into three layers, right? There are application layer organizations, there are platform layer organizations, there are technology layer organizations. In my X, I put it as product and services. So that could be customized services and productized services. This I'll ignore. So application is always on an assumption of a very good infrastructure, which is platforms, right? So today robotics is not yet there. We are somewhere at principles level, right? Foundational technology has to be built. This is where we need to come all the way up towards, right? Now the customer who can create a product which is a reflection of the technology that you have today, who can handle you structurally, the industry that has formulated a structure for it is automotive, because they have been profitable with a dumber robot. So they know how to be profitable with a slightly even intelligent robot. They can incrementally start creating commercially viable space for you to kind of start solving. But they are very slow. There are a lot of things to go into. Even for them, they do not know yet how to reflect and what to expect out of machine learning. Sometimes they expect too much, sometimes they expect too less, sometimes they don't get the right commercials for it. So there's a lot of these. So robots today cannot replace, in the next 4 to 5 years, cannot replace man labor, right? They can displace man hours. So displacing man hours is where you will have to begin with. Where across 5 different tasks, one system is able to carve out, 20% of the time, because of which you are able to replace one person, right? So to learning to think on this line, and customers reflecting problems and giving problem statements that are on this line is a missing piece in the robotics division. So another easier space that we can actually think about is lab automation. To a large extent hasn't been touched. So that's a very interesting space. There is also a lot of semiconductor equipment manufacturing and equipment design. Not the fab lab per se, but the machines that go into the fab lab. So that's a largely underlooked space, which also has a good margin. The problem I will say with automotive is why I'm comparing semiconductor to be better spaces. You have, especially with non-luxury segments, volume segments, right? Like GM and Ford, you have a 45-second limit. For them to be commercially viable, your robots must be capable of delivering the task within 45 seconds. Getting it functionally do something in a open context itself is a unsolved problem yet, right? In a moving car, wire an airbag curtain swinging left and right. That was the first problem that was given to us by GM. And then your robot being able to track it, attach itself with that, pick that, and then figure out which orientation it is, and then attach it to to the screw hole, pick the bolt, put it to the, then put a washer. It's all dual hand activity while coming into the car chassis and then looking out like this and then doing all this. Right. So that's imagine how complicated this is. Now, achieving all this with the maturity that we have today in 45 seconds for the task to be finished. Right. That's too much of a far fetch in many cases. So those are tasks that are not not uh, maybe technically you could do it some case specifically 1 in 100 times it might work, but making it work 99 times in 100 times or 99 point, I mean, 9,999 times in 10,000 times. That's three sigma, right? So you need to kind of hit there. Is a very, very, that maturity is a product maturity that you need to hit, right? So that is a easier task done in a semiconductor space than done in automotive space. Second, you need to hunt for customers who look at this as a business transformation for them, an essential business transformation for them, not as a cost center automation. So the more you are a cost center automation, the more stringent will the expectations be, and you will not be able to meet that. And you will have POCs after POCs after POCs, but nothing will materialize. So you need that Amazon moment for Kiva robotic systems, which became Amazon robots, right? So I had the fortune of talking to the, so when we were recruiting for someone in to lead North America, um, there was this person who technically led this merger with, or like acquisition with Amazon for Kiva systems. He was saying Amazon had no idea. They had no idea that a warehouse market exists in 2007 or 8. They were going to automotive customers, POC after POC, 3 years, nothing happened, 4 years, nothing happened, 5 years, nothing happened. Till somebody from Amazon thought that maybe we should try an automation in large scale like this. Today we have a warehouse automation industry in itself, independently have emerged. So robotics also needs such a junction of it to happen. That could be and semiconductor equipment manufacturer and so on. So because they have time. Plus, they have more margins. A luxury segment car manufacturer also has more margins, and that could be a very interesting space to go in. You have slower. You look at productions that are more complex, but has more time. In a closed loop system, it can figure out to complete the task if you give sufficiency of time. In the intelligence space, it'll attempt multiple times and it can figure it out if you have tightly engineered it, tightly programmed it, and in corner cases you have handled and then you have trained the system effectively, time will be the biggest issue right now. So pick a task like a server farm maintenance, right? Pick a task where you have enough time available, while it has you can justify the through the versatility that your robot actually has,
Interesting. Okay, got it.
right?
Okay. Any particular robotics founder you're fond of, and a robotics company in general about the way they have done it in their own sector? Someone you either follow or someone you are in touch with? Yeah.
There's also a personal ego, but more than that, I look elsewhere largely to I can't pinpoint to one particular industry, and there's a lot of
Mhm.
things that you get inspired from a lot of different,
Yeah,
like
for sure.
Henry Ford is a very good inspiration for me from the way they thought through an IC engine and then the way he imagined future of manufacturing per se on one side, right? So
Right. Hmm.
and Nvidia have always been a
Hmm.
I have been a passionate follower of him from past almost 15 years now, right?
Okay.
ARM is a very interesting company for me
Hmm.
because they're all foundational technology company,
Right. Right.
and they have to build, they have to foresee this when your customers are still studying in school, right?
True.
When
Well said.
GPUs,
Yeah.
you could have never imagined there is cryptocurrency that will come. There will be neural networks that
Right.
will come, and that will change the
Hmm.
the odds for the company and so on and so forth. Right?
Right.
So of course you can't miss Apple. It's never. I mean,
Hmm.
from a methodol, I didn't appreciate him then.
Hmm.
I started appreciating Steve Jobs more um, now
Hmm.
in last
Interesting.
few years per se. I've not read
Right.
per se so much, but the thoughts many times things that I come
Right.
up with and people say, this is something mirrors with. So I could see that they have
Right.
gone through the same pain, and
Hmm.
so from that
Right.
manner, I even like TSMC in the way they have built things, and that Toyota is always a great inspiration in the way
Hmm.
they structure and build. These are all companies that have created a large ecosystem under them, massive
Hmm.
operations. That if you do the Thanos snap and then some of these companies vanish, we take it for granted. But if they vanish, right, the world will come to standstill, right?
Yeah.
So it will not move.
Yeah.
It is life threatening in
Yeah.
to massive loss of life in most cases.
Right.
Whereas a lot
I
of
think. I
surface
think.
level, sorry,
Yeah. No, no. I think even from this answer, it shows on to see that you are very excited about the foundation of any model or any kind of industry or anything that you're building, right?
absolutely,
Yeah.
absolutely.
You think that VLA or world models which are now coming up for robotics, right? Is would that be a moment wherein we kind of get robots much more nearer to the general purpose?
It's
Like how Scalia is kind of committing that their software can actually be used on any form factor of a robot,
right,
their training. So yeah,
right,
which is what actually even your company, I think you say that one
yeah.
robot used for multiple
Multiple
products.
profit.
So yeah.
So that,
Hmm.
that is a philosophy. Robot per se was actually thought from the philosophy, right? So everybody who wants to build a robot, I've always thought about
Hmm. I
that
guess.
one form factor scaling to multiple different applications. General purpose machines is what
Hmm.
robots are. Like we say general
Hmm.
purpose robots, but actually robots are actually general purpose machines in first place, right?
Hmm.
So that's the foundation
Okay.
thought, right? Uh, Today robots have taken it's a new term to market machines, right? A vacuum cleaner becomes a robot, and the robot as a term was coined to say they are intelligent machines, right? So the machines that can take decisions and so, so that's still an absent space. But from coming back to the VLA aspect of it, see, so always we have to be very careful in this space because human personification is an issue. So so what it appears to be and what it actually does foundationally is a very different two different things. We have got a new UI, a new programming interface, right? That's a new compiler. Instead of a C++, I have another way of instructing missions. But translating those instructions into an action, that's like, I have a compiler which is compiled into an assembly level code, right? Which is machine interpretable, but I don't have a machine which has those circuits to process them, right? We have a lot of absence from a foundation layer point of view, right? So if I say go and pick some object or pick that particular velvet or that delicate object, you don't have to say it's delicate. You will interpret that it is delicate, right? So those are primitives that are inbuilt into human beings to kind of adapt and then do that. That action primitives is missing. There are sensing primitives that are actually missing. All that I'm able to do is to using the global knowledge that is available, I'm able to interpret the context to a good extent, right? But how do I translate it to verbs? Many of these systems do not have verbs. LLMs do not have verbs. They're hyper tokenized systems which understand patterns of sentence construction to a very good extent, but doesn't mean that it understands catching a tennis ball versus a cricket ball, what is harder and what is lighter. They don't have pain. They don't know the impact of force. They don't know what happens. Like if you watch, simple example is if you watch a guy picking a 100 kg sack who's usually that the labor who's actually lifts the rice bags. For it will feel like it's easy. I also can actually lift and do it, right? But only when you go and lift it, you actually know how complicated and how hard it is, how energy consuming it is, what all tactics and tricks that are actually there. What is he doing for him to kind of balance that object per se? We miss physics of objects. We need to work backwards from physics of objects, and then it will have to meet to VLA. And VLA is one form of instructing the mission. In addition to just because mouse is there, you didn't replace keyboard, right? Just because you had touch, you didn't replace keyboard in your mobile phone, right? Just like that, you have another way of commanding the machine. Doesn't mean that rest of the other input means you will not need a UI, you will not need a, configuration guidance, teleoperation. All of this will be a mix of things that will be there. Translating them into final action to the form factor of the robot, whether I have 3 fingers, 5 fingers, whether my hand has 6 joints or 7 joints, what kind of force torque sensors it may have, what will be the force patterns it's supposed to understand. There's a lot of those primitives that are missing in the robots today for you to effectively exploit the VLA's growth, right? VLA is not the final means of it being able to go and pick an unknown object or unfamiliar object per se, right? It could be a good means to make it faster for you to program, but I still find it as robotic arm programming wasn't a very hard thing. You were able to do a joystick and then move the robot and so on. So giving them context of decision was the biggest problem, right? So so that is where the focus has to be. And VLA is just an extension of LLM to just see if something could be done on the robotic space or not. And it'll again fizzle the way OpenAI's manipulation stack fizzled after a point of time. So that could happen, right? So if we hyper before this interest drops down, start focusing more on the foundations, which requires your neural network in itself to be rethought. There's so much of reinforcement learning blocks that are missing. There's so much of constructed sensors that has to happen. Your brain constructs a lot of sensing internally. Like those layers are actually missing. That formulation of what the color means in terms of force, that connect has to be found. And there has to be standardization so that you can borrow one robot's learning to another robot's learning. Like I'm able to, you may have a completely different laptop, I may have a completely different laptop, but we both are able to kind of use the same software and then be able to do that because the abstractions have happened from the architecture in itself. Both of us are using x86 architecture, right? That makes us, someone developing in a completely different machine, be able to transfer it to a completely different configuration of the machine. But the foundation was common. We don't even have the foundation first. Without which, how will the system, right? So all this data that we're talking about, data first of all has been structured. Image has been structured. You have a JPEG, PNG, color, all of this has been properly structured, right? We don't have a circular image. We have a square image, right? For that, a memory system has already been structured. There's so much of layers that we are not seeing why this was feasible. And what equivalent of that is missing in the robotic space to be built. So that's what we particularly talk about as an object intelligence say. So we are looking more from object backwards. If something has been hard to solve, it's not about you tinkering with the robot form factor, but we not understanding the problem per se. The problem is the object. So something about the object we are not understanding, and then we are not equipping the robot to handle those aspects of the object, those changes of the object. So what is that is needed, and then what all has to be built around it? What all intelligence layers are supposed to emerge on top of them to be able to handle this? So these layers are the primary focus. I think that's the space that we also have, considering that there is enough of interest towards VLA as well. So if people will improve. If we parallelly work this and then merge them and blend this, then we have a more holistic end-to-end solution, a value for the customer per se. So which can uptick the market. So today there is a lot more to complement in robotic space than to compete per se. So
Right. Got it. Okay. Interesting. So I'll just have two more questions for you. One, can we talk something about your Mantroid robot that you are saying that it's coming
yeah,
soon? It's the design seems very interesting. So is there anything that you can share about that?
sure. I mean, it's still premature, and it's at the concept level for us. It'll take at least 2 years for us to complete again, figure out our supply chain for it, commercial viability, pricing, and so on and so
Okay.
forth.
So, like, what are
But
you thinking about it? Like, or what are you thinking about
why are we? Yeah,
Cynlr as a
why does
company
that
to 10
understood?
years down the line? Yeah.
Yeah. So the reason for Manfride largely is, there's so much of energy and compute wastage on balancing the robots, especially
Mm-hmm.
the robots that are not built with the same mechanisms that human body employs for balancing itself. Our actuation itself, so kinematics wise, we might be similar, machines might be similar. Dynamics wise, they are not. The way we actuate our hands and arms are very different from the robots. Robots are joint actuated, right? Here, these are all largely muscle actuated, and then everything is an active sensing. There's a lot of weight shifting and balancing that the body actually does, and so on and so forth. So, and many a times we sit down to do the work, then walk and then do the work. We don't actually walk a lot when we actually do the work. If you observe, even when we stand still, we find our stable places, or we sit in the factory and then we work, right? We don't move and work in most cases, right? So that is also like underestimated or underseen. And because it is easier for you to get because of Boston Dynamics stack that has been there, commercialization of this, showing maturity of this, and then trying to hope that there will be some commercialization that will arrive at it is how the market is going at it, right? It's on the other hand, the advantage that it brings than the AML kind of a system is you're able to cross and walk through. I'll still prefer a wheeled system, but a wheeled system that has an advantage of multi-terrain operation, right? So you can cross through complex environment. A wire in between is enough for you to stop a AMA. And if you see most of the floors, they are cracked. They are not very even and so on and so forth. Items are always lying in the way. And so you need a system that could navigate around them, squeeze themselves between and so on and so forth, but without having to have the need for balancing so much, but also have the ability to have battery power to sufficiently power all of these systems. And the third aspect, we believe uh, in an upper torso that has the hands at the hip, not at the shoulder. And that gives extra freedom for your head. So you could go and see from multiple different orientations without having to shift your body and so on and so forth. So this will be a good combination, and the reach it can actually go. So if you see the pictures, the kind of reach it can actually get, the kind of viewpoint it can actually get, the activity that it can actually perform, it opens up a lot more possibilities and freedom. But at the same time, it can become as sleek as a human body when it's needed, right? When you want to balance, it becomes very easy for you to kind of step over. At the same time, if you want to navigate through a complex space, you can navigate through a complex space. And it's not a four-wheel system. It's neither a two-wheel system where your a lot of your energy and control is gone in trying to stabilize your body, right? And wheeled is way more efficient than walking for a continuous operation. Let's say if a car is moving, a wheeled system is more less frequent to variations and oscillations than a legged system. All right. So all that is an advantage. It's basically a combination of leg and wheel. In the process, what we are trying to do is we will create a sandbox for the customer to come up with static machines, sino form factor, sinoid form factor. We don't know which form factor of a laptop will work out today, right? When you're in 1980s. We are already talking about whether a 15-inch laptop or a 16-inch laptop when you have a Lisa computer, right? I rather want to give the customer the Lisa computer that he can, change the motherboards, change the, so a new gripper comes, you should not be, stuck with, oh, I've spent $200,000 on this robot form factor. Now what do I do with it? Could I change this? What if my hip joints become really better? So what if I could just, you know, like a Lego block kit, more than Lego block kit, basically like a assembled PC that you can just, we define only the common connectors between them. And then we have distributed compute for each of those joints and controls for each of those joints that can seamlessly go with each other. So the customer has, flexibility and protection towards his investments with a future scalability, right? So he's
Got it.
protected from obsolescence with a fast evolving technology, because in the
Hmm.
next 2 to 3 years, every day you'll have new grippers coming in. I mean, your
Right.
LinkedIn posts are largely like
Yeah.
plethora
There's
of different
every
missions,
day
and
there's something new coming
every
up.
day something keeps
Exactly.
coming
It's
up, right?
crazy.
So
Yeah, yeah.
yeah, and that's a good thing, and that's how robotics
Hmm.
is supposed to evolve. Finally, that moment is happening, right? And so all the way till motors, there are modifications that are happening, motion systems modifications are happening, right? So this is very beautiful set of foundational component level improvements that are actually happening, right? So, and initially people used to believe, oh, we have figured out motors for EV that could be used. EV motors were never meant for precision. They are very different from the velocity control. They're not push and control machines. Your whole winding concept changes for how you would actually do for your cogging and so for a motor is going to be very different, right? So battery technology has to evolve drastically different from what you could use as lipo for your cars, right? and the attachability, detachability for the systems. I have a big problem right now, right? So we wanted to keep it as one single phase system, and so that it's easy to plug and use everywhere, so that you don't need industrial connector of a three-phase 420-volt socket where you have to go. But my robot is reaching the single phase maximum limit of power. Now, you have to come up with an algorithm where all three arms are not operational all the time. So the task it actually starts computing to say whether this hand is going to pick that object or the other hand is going to pick that object within this stipulated time of, let's say, 20 seconds within which you are supposed to complete this task. It still has to figure out which arm is supposed to spend how much energy, so that you are not crossing the maximum of 3.2 kilowatt, so that you don't trip effectively. So the battery systems has to come, the power systems have to be rethought around this. So all this is
Hmm.
what we hope to kind of build as an ecosystem for the customer
Right.
to seamlessly think, for based on the commercial case, based on the ease of evolution case, and also
Hmm.
for the application case, customer has the
Hmm.
flexibility to concoct
Right.
the mission
Right.
that they want. And Android is the superior form, the most superior form that you'll
Right.
get.
So, like, apart from your own products, it will be very interesting with the way you think. It is very interesting to see how do you see in general world, 10 years or 50 years, 15 years down the line, in terms of robotics. What do you see? Like, how much of robotics will we see around, and in what sectors or in
See, in
what
my
way?
mind, I
I guess.
always run a science fiction,
I know
and
that's why I'm very interested to know knowing
so
about now
uh,
yourself and like the way you think. Let's just go with your flow.
for me, I'm very so the whole. When I said the initial story where I started from, all this is basically the science fiction that was running in my head. Largely
Yeah,
that
yeah.
that the possibility of what compute world did to the world today, the
Right.
compute technology did to the world today.
Yeah.
Imagine multiple folds of that happening for your kitchen will not look the way it is today. Your house will change, right? The so if you come to the office sometime, we have a poster, a large poster that always stays in my laptop and everybody's laptop screen. So you don't believe in this vision mission statement. People have to just, get on to a science fiction ride in your mind. That's the vision that you will. It could be any of those stories of what it could actually lead to. Imagine you go to Thailand and then you come back and you ate something. It was very interesting cuisine, and you wanted to have that here. And if that guy earned a lifetime customer for it, but if he has to monetize that customer, the amount of expense that you have to do is to come back here to India, start a franchisee, put a brick and mortar setup, locally source the material, ensure that the cooks are trained, and then and then you have to get 100 other customer to sustain that business, the investment, so that I can serve you. So he has to get another critical mass of 100 of the customers and things. But imagine like a Zomato app, you open it, and then 30 minutes or within 30 minutes or it's free for you, right? And the whole dish comes from Thailand to your home, to your kitchen, through optical fiber cable. How? Because we are imagining this to be the computers of the future, which are object computers, right? So the imagining becomes cheap enough at some point that you could have this machine in your home, and he can also have his machine at his place, that your grandmother's recipe or his grandmother's recipe, you can just upload, teach that system. Recipe is just an action, right? It's a flow of action of the same ingredients. You change that, it becomes a sambar or a rasam, right? So that's all is the difference, right? So you do that over there and then you upload it. You could just download that here, and the robot just figures out for your tools and your vegetables, your things, and then how to kind of convert it all into an action per se, and then cook it for you, right? And if it's possible, then we may actually remove the kitchen from the house in itself, because you could have a centralized system where you just upload your mom's recipe, your recipe, your grandmother's recipe, or whoever's recipe it is, and you could just, get that from there. To imagine your factories of the future not being gigafactories, but they are all universal factories that can produce your mobile phone to your laptop to your car in the same factory, but it will all be in your service centers, fragmented, fractured micro factories, franchising your manufacturing per se, right?
Right.
And each of your car could be to your size, your shape, your customized products, right? Customized
I think this
consumables.
is mentioned even on your website. Yeah.
Yeah. So I mean, this is something is it's a very passionate thing that I kind of imagine, and farm
Right.
integrated production per se, right? That the value addition happens at the farm layer in itself, that you don't have to do, a centralized. Today, a lot of energy is lost, transportation energy is lost because a lot of centralization has to happen for everything, right? And a lot of businesses become unviable because centralization was not possible. I'm not able to centralize talent. I'm not able to centralize infrastructure. I'm not able to centralize supply chain. I'm not able to. So only a few products are feasible today because this of the centralization problem. So gigafactory is not the answer, right? Imagine every home at the end of it starts becoming a mine per se, right? The supply chain comes from your house. When your phone is dead and then it's has lost its life, the raw material for the new phone that you want to buy should not come from earth. It should come from the same phone. Why is it not possible today? Because the effort is expensive, right? The effort of converting the raw material to the phone is cheaper than extracting the raw material from your phone to the new phone, right? What if that effort becomes free, right? Imagine under your apartment sorting out you have distribution chain instead of a supply chain, right? Which is an inverted triangle converges to a dustbin, right? More than you, your dustbin is the biggest consumer, right? So landfill is the biggest consumer.
Interesting.
Imagine
Yeah,
that
yeah,
becomes a
yeah.
distribution chain, largely to that
Sure,
extent,
sure.
right?
Mm-hmm.
So,
Very
so
interesting. Yeah,
the way
yeah.
you would step out of your house, it will be different.
Yeah,
Your
yeah, for sure.
livelihood
For sure.
around what you could imagine will largely be
Right.
different. So for
I think
me,
any product that you get or you buy, there'll be like a high possibility wherein it's never touched a human. It's all
correct.
being either
Even today it
procured
is.
by a machine and yeah, most of
Even
like
today it
yeah.
is, right? Imagine the air that I
Maybe
breathe now.
automobiles. Mm-hmm.
You know, the headphones, the shirt that I'm wearing, the food that I ate,
Mm-hmm.
the rice and the sambar or the curd or whatever you're doing, everything has come through machines today, right?
Mm-hmm.
So the air that I breathe has largely come from a machine. And it's an AHU that is sitting there and then especially pumping it. We are already touched by machines end to end, right? Humans are just there to kind of put their hand somewhere in between. The major tasks are performed very largely by the machines. That will become even more versatile. The machines will become more versatile that you could transport one machine's learning to another machine's learning, and then you have so in fact the future of it, this is the object computer. Then what would the future of IT look like? People sitting beside in a office and then teaching robots how to handle new objects and new tasks will become, and they upload these tasks and recipes into your task store, and you monetize over people like an app store, people kind of downloading this and then using this across. And then,
Yeah,
then
for
and
sure.
universal learning for robots also happen. Because at one spot, if a
Right,
customer
right.
trains for a bolt, it's
Everyone learns
transferable.
it. Yeah.
Exactly. Those
Mm-hmm.
models could be
True, true.
portable across.
Yeah.
So,
I
so
even
kind of
I do think about food a lot, like food and robots, because it's like every like love food. So and of course love robots. So you like most of the times I'm thinking on that
it emerges
terms
now.
of automating. Yeah, yeah, yeah. Of course. It's so exciting and it's like endless. Like once you get on that
Think about it,
imagination,
you
like you
run the
can't
train,
yeah.
it just goes
Yeah,
on.
you can't
It
stop. Exactly.
can't
Yeah.
stop. Yeah.
Okay. Any advice that you would give to anyone who's listening to this, mostly people from the robotics ecosystem? What is it something that you would want to share with them?
More than an advice, it's just a learning. I mean, expect this to
Mm-hmm.
be a turmoil. If anyone wants to start in this space, expect
Mm-hmm.
this to not to be an easy journey. And if it's too easy, then there is something wrong because entry barrier for this space is very high. And I would say it will be futile with an absent ecosystem to just go chasing low cost, low cost, and low cost. Please don't do that. Start looking at robotics needs a lot more of efficient mind to be applied for foundational technology to be built. Start from the skin sensors, the motors, motion systems, the modularity of grasping, the algorithms behind them, and there's plethora of things to do. The control, the ICs that are needed for them. And if you want to build something on this, don't go robotics engineer. That's a useless course to take. Start learning the fundamentals. Like I need an electrical engineer to build the motion system for the robot. I need a control engineer. Focus on controls. That's very, very foundational. Even before you jump into RL, reinforcement learning per se. Controls foundationally, you can't skip it. It's only an increment on controls. It's not an alternative to controls. So foundation of controls has to be very strong. Perception. and programming skill is a must. It's go back to your basics, go back to the C++, go back to that foundationally. You can't skip that. A lot of delay for me today in whatever that I'm supposed to do is also because of that absent talent space in these. So if you want to make that frontier pushing improvements and efficient systems that is commercially viable for me to take it to the beyond a customer prototype, a POC, all these productization bottlenecks you will actually hit at, right? And you need these skills. You need these foundational skills.
Any particular way you think that these skills could be developed so that you and every other robotic founder who's facing the same issue, that we don't find that correct talent? Any particular way anyone can address it, or someone who's trying to build a skill like build it?
Yeah. I think for the experienced folks, just go back to what you were doing like 10 years before or 10 to 15 years before.
Oh.
Uh, so that is necessary for you to again, but don't drop what you have learned thus far in the new age tech, right? So, but remember and recollect what you've actually done. For people who are stepping into it fresh, who are like out of college and so on, your fundamental subjects and control systems is a must. And when you're learning your engineering, don't think about robotics. Just pick a product. Like let's say a fan, let's say an AC. Try to imagine to build that from scratch, right? Into it. Try to learn why different aspects of engineering is needed, because robotics is one space where every engineering field has to merge in, has to be combined in, and everything needs to be deep. Today we are combining them at a surface level. Everything has to be foundationally built, right? You need to be very comfortable with the maximum precision of a motor is always built in robotics, right? You push the limits of motor precision in robotics. You push the limits of sensing in robotics, right? My camera generates a GB of data, 8 Gbps of data per second, right? And this is raw. And then I have to look at my pipeline of processing after that, right? Now imagine squeezing this into a compute power that is only as good as your laptop. I can't have the luxury of having a very powerful server to which I can hook because time delay. We are talking with Ericsson now, thinking about why can't I have wireless modular joints that a robot can borrow joints from each of the hands per se, right? And why are we stuck with physically connected communication signals for real-time communication when I can have a pointed directional antenna system between optocoupled or at a microwave frequency that we can actually have these two merge together, right? So all this is the foundational. You have to touch RF, you have to touch, and you're thinking of a skin that is made of RF rather than physical skin, like a ring that you can actually put and then it just starts. These are all like future things that we're actually imagining, right? So that is where the scope is for any robotics engineer per se, in making those foundational things, not in the concoction and on the contraptions that you build with moving machines. Moving mannequin always looks more interesting and intelligent than a sitting human. So that doesn't mean that the sitting human is less intelligent. So look at that whole perception stack, control stack. Motion is part of your sensing. Motion is not the end result. So that way you should include them. So if you're going about trying to pick these skills, go back to the fundamentals, try to borrow how to productize on one side, how to fundamental engineering components, how to build them on one side. Meanwhile, people who are experienced, just look back at where you started, go back to your C++ fundamentals, go back to your machine design fundamentals. Uh, and the way the AI space is going, I think that's where your future scope is also. That's it. So
Hmm,
need more
got it.
engineers.
Okay, wow, interesting. We have covered everything from matrix to whatever future, how future cooking and how future transferring of action would look like, I guess. And there's still so much more there. There are so many more questions that I have. I'll definitely connect with you again somewhere down
I'll
the
chat
line when
another
you
time.
have
Maybe you can call me
bigger.
out.
Yeah, definitely. Like when you have like much more bigger teams and much more products out there, I guess. I guess you'll have much more to add to the journey of whatever it is that you've had until now, for sure. So yeah, definitely looking forward to visit the company, to meet you
Please
again,
do.
and
Please
to
do.
sit with you again and get into more other details of future.
See,
So thank you
our
so much for doing
good luck.
this. Thank you for your time, and yeah, all the
Thank
best.
you. Thanks. Thanks for this opportunity.